Unit 4 Chemistry, Chapter 15, looking now at structure and bonding in food molecules. So there are a range of different types of food molecules we're going to look at. These are biological molecules, so they are organic chemicals. Some of them can be quite large and complex, some of them are very simple. Okay. The first is the lipids. Now this is a diverse group of biomolecules, some fats, some oils, some steroid hormones, etc. The ones we're going to look at in detail are the fats and the oils. The others, the main characteristic they've got in common is that they are insoluble in water, and their main elements in them are carbon and hydrogen. The fats and oils we'll look at in more detail. So the first thing to bear in mind is that they are triglycerides. Now, you may remember this from when you studied way back in transition biodiesel, which is made from a triglyceride, an oil. In that triglyceride, there are three ester groups, okay, and they're formed by a condensation reaction between an alkanol, specifically glycerol, which has got three OH groups, and three carboxylic acids, long chain ones which occur naturally, which are called fatty acids. Okay, so to make any ester, we have a carboxylic acid group and an alkanol, and they're linked together in the presence of acid, and it's normally sulfuric acid, and we make this ester linkage. And remember, the ester linkage is the carbon and both hydrogens. It's a condensation reaction because we remove water. Okay, so if we make a triglyceride, our alkanol is propan 1,2,3-triol, which we normally call glycerol. The carboxylic acid is a very long chain hydrocarbon, which might have single or double bonds in it, okay? And that is a fatty acid. So this is our glycerol with its 1, 2, 3 OH groups. We can have three different fatty acids. Okay? In this case, all three of them are the same, so they're all stearic acid. So we're going to make tristearin, which is a type of a triglyceride. But we could have two of one type and one of another, or we could have all three being different. The formulas of these fatty acids and their names is found in your data book. When we react all three of them, of course we therefore make three ester groups. The fatty acids can be saturated, alkanes, or they can be alkenes. If we say something is saturated, it means it's got all the carbon-to-carbon bonds are single bonds. If it's monounsaturated, it's got one carbon-to-carbon double bond. And if it's polyunsaturated, more than one carbon-to-carbon double bond. It's important to specify carbon-to-carbon, because if we look at it, they've all got a double bond. They've all got a carbon-to-oxygen double bond. So it's not enough just to say the unsaturated ones have got double bonds. They've got carbon-to-carbon double bonds. Now, some fatty acids are what's called essential, some are non-essential. If we say they're essential, that means it's essential that you eat them, because you can't synthesize them in your body. If they're non-essential, you can. Okay? So the omega-9 ones are non-essential. Omega-3 and omega-6 ones are essential. And here's some examples of sources that you can get them from. Okay, so fishes, you can get them from walnuts, you can get things from primrose oils. Okay. When we talk about omega-3 and omega-6, what we mean is where the double bond is, or the first double bond if there's more than one. Okay. So normally we count from the acid end. If we count from the other end, technically the wrong end, but that's what we mean by the omega, we go other end, and we count in 1, 2, 3 carbons. That's where we find the double bond. So an omega-3 one has 3 carbons in from the wrong end, and omega-6 has 6 carbons in from the wrong end. The length of the chain in total doesn't matter, it's just how many carbons are we in from the methyl end is the other way of talking about it, because it's the end with the CH3 on it. They're really important because they're used to make things that are in your cell membranes. And your cell membranes are essential to determine what goes in and out of your cells. Okay? They're also used as precursors for other lipids, which means we make stuff from them. Okay, so there are a few different ones. As you can see, some of them have got multiple double bonds, okay, but we count from this end until we get to the first of those. So these are all omega-3s. These two here are omega-6s. Properties of fats and oils. So fats are solid at room temperature, oils are liquids. They're both triglyceride. The fats are solid at room temperature because they have mostly saturated fatty acids, and they pack together more closely because they're straight. So if you had 3 of these, they can fit together nicely. Anytime you get a double bond, we get a kink in the fatty acid chain, and that means that they're going to be more spread out, so fewer dispersion bonds can be made between them, and therefore we're going to get a reduction in the boiling point, so they're more likely to be liquids at room temperature.